So this is the second video in this lesson about factoring trinomials, day number 1. Following the steps from the example above, I asked myself, is there a GCF for each one of these terms? And in fact, there is. 3 is the GCF. 3 divided out of 3x squared is x squared. 3 divided out of negative 15x is negative 5x. And 3 divided out of negative 42 is negative 14. The next one is to set up an area model. So I put my first term here. I put my last term here. So 3 is still my GCF, and I'm trying to figure out what are the factors that will multiply together to make this trinomial. What times what makes the first term? Well, that's x times x. And then I ask myself, what are the factor pairs for the last term? Well, it could be 1 and 14, or it could be 2 and 7. Which one do I want? I could try 1 and 14, or I could try 2 and 7. Let's see if I tried 1 and 14. If I put a 1 here and a 14 here, I would have 1x and 14x. Then to check and see if you're right, you say to yourself, what is the combination of these two? Oh, and I have to think about the signs as well. This is a negative 14. So one of these has to be negative in order to make this negative. So I'll make this one negative. So it'd be negative 1x. 14x minus 1x would be 13x. Is that what I want? I'm not looking at this. I'm looking at this because I took out the GCF to write in this area model. Nope, that does not match. So 14 and 1 could not be it. And I don't think that switching their positions would make that much of a difference. So let's try instead, let's try a negative 2 and a 7 and see how that works out. So x times negative 2 is negative 2x. And 7 times x is 7x. When I combine these two, 7x minus 2x is 5x. Is that what I have? Ooh, I'm so close. I want a negative 5x. Ooh, I'm so close. What should I do? What would happen if I switched the signs, if I made this one a negative and this one a positive? Well, in that case, this would be x times positive 2, and this would be x times negative 7, and now negative 7x plus 2x is the negative 5x that I want. Hey, so now that I know that my area model is correct, my first factor is x minus 7, and my next factor is x plus 2. Another way to check and see if you're correct is to double distribute and say x times x is x squared, x times 2 is 2x, negative 7 times x is negative 7, and negative 7 times 2 is, negative 14. And these combine to make the negative 5x that you want. But really, this double distribution is just redoing the work that you've already done in the area model. You don't have to do that. So my factors, that's this expression here. Moving on. There is no GCF to deal with here. So I'm going to put x squared in the first spot. I'm going to put 2 in the second spot. I ask myself, what times what makes the first term? X times x makes the first term. What times what makes the last term? 2 times 1. Now I have to play with the 2 and the 1 and the signs. This is positive. So I'm either going to have 2 times 1 or I'm going to have negative 2 times negative 1. And it seems to me that it makes sense to do a negative times a negative because I have a negative term here. Let's see if this works out. X times negative 2 is negative 2x. X times negative 1 is negative x. When I combine my like terms, negative x minus 2x is negative 3x. Does that match the middle term that I have? It does. So my factors in this case, no GCF to write, is x minus 1 and x minus 2. If you wrote this like this as x minus 2 and x minus 1, that's perfectly okay. Those are the same thing. How do you know when you finished factoring? You know you're finished factoring because nothing in these expressions, not this one nor this one, there are no more x squared terms or t squared terms or a squared terms or whatever variable you're using. We'll talk more about this in future videos.